Hey, so hello and welcome everyone. So this video is going to be a walkthrough of the solution to the second exam in my intermediate micro course. Lots of times with these videos I like to show the exam kind of like a blank version first so you could test yourself. I'm not going to be able to do that with this one. This is the only version of the exam that I have on this machine, and so I'm just going to have to like run right through the solution. Nevertheless, like lots of times you just like to see the answers or like kind of work through and kind of check your work as you're looking at the solution anyway if you're using it for self-study later on. So I think it'll be fine. Like I said, this is the second exam in the intermediate micro course, so it's basically producer theory. If you're picking up with Varian, it's like picking up with the technology chapter, profit maximization, cost minimization, cost curves, monopoly, and then monopoly pricing or like sophisticated monopoly pricing up through price discrimination. And so that's what I like having on the second exam. That's what's covered by this exam here. All right, so begins with a collection of multiple choice questions. So the first one, if output is produced with two factors of production and has increasing returns to scale, then which of the following is correct? So there can't be any diminishing marginal rate of substitution. All inputs have increasing marginal products. On a graph of production isoquants moving further or moving along a ray from the origin, output more than doubles as the distance from the origin doubles. Marginal product of at least one input must be increasing. All inputs must have decreasing marginal products. So it's C, right? It's the one that's bolded anyway. What's going on here is it's saying if we're going from moving along a ray from the origin, what does that mean? I should have drawn a picture. I bothered to sketch out everything else. I forgot to sketch out this one. So remember, isoquants are giving us along the Cartesian plane where the horizontal axis is, for instance, labor, and the vertical axis is, for instance, capital. The isoquants are giving us all the combinations of labor and capital, or whatever are the two inputs that give a single level of output, right? Just like in difference curves, we're giving us all the combinations of, for instance, good 1 and good 2 that gave us the same level of utility. Here, with isoquants, the idea is we've got all the different combinations that can produce the same amount. Okay, so as we're going out to higher and higher isoquants, though, we're getting larger and larger quantities, and we're increasing the amount of both inputs, right? If we're moving on a ray, for instance, if we're thinking about this ray from the origin as like the 45-degree line, we're using increasingly larger amounts of both of the two inputs, giving greater outputs. If output more than doubles as the distance from the origin doubles, then what's happening is, as we're doubling the input, we're getting more than double the output. That's exactly what we mean with increasing returns to scale, right? Constant returns to scale was double the inputs, get double the outputs, and decreasing returns to scale was double the input and get less than double the output. And we showed, like in one of the videos, I show how you can demonstrate that formally. That wasn't necessary here. You just needed to answer the question. All right, so suppose we have a new metal alloy that's discovered using copper and zinc in fixed proportions. Each unit of the alloy requires 4 units of zinc, 2 units of copper. No other inputs are required. Price of zinc is 2 per unit. Price of copper is 5 per unit. Total output, 4,000 units. What's the average cost per unit of output? All right, so basically what we want to do is find out what's going to be the requirement to produce each unit of output. So the way that obviously could just divide my answer by 4,000 from the get-go, right? But what I want to do is say, hey, wait a second. I want to take seriously the fact that we've got these fixed proportion Leontief production technology, right? It's telling us for these 4,000 units of output, we're going to need to use 4 units of zinc, right? So 4 times 4,000, and that's going to cost us $2. And that's going to be a total cost for zinc, or total expenditure of zinc, is going to be 32,000. And then at the same time, we're going to have to use 2 units of copper for each of the 4,000 units. So a total of 8,000 units of copper times $5 per unit of copper is 40,000. The total expenditure on producing those 4,000 units using copper and zinc was 72,000, and then I'll divide that by the unit of outputs so I can get the average cost per unit of output. That's $18. Right, so that's C. All right, so we've got a production function 2x1 plus x2. So this is perfect substitutes, isoquants. If the factor prices are $8 for factor 1, 5 for factor 2, how much is it going to cost to make 70 units of output? Right? What we got to do is figure out with perfect substitutes, is this going to be an all X, all Y, or maybe some mixture to be able to produce those 70 units? So to do this, we want to think about the map of the isoquants and their slope, isoquant and its slope relative to the map of the isocosts, right? So the isoquant here the one that's going to be corresponding to 70 units of output is going to have a slope of what, 2. Matter of fact, all the isoquants are going to have a slope of 2. It's just the MRTS is going to be 2. It's just that we're particularly interested in the one that's going to give us 70 units of output, right? So this is corresponding to 35 units of good or input 1 right here. And then our isocosts are going to have a slope of omega 1 over omega 2, so it's 8 over 5. Well, 8 divided by 4 would be 2. 8 divided by 5, something less than 2, right? And so these are going to be flatter. The lowest isocost is going to cross the isoquant right down here. And the idea is we want to produce this output the cheapest way possible. So I'm looking for the lowest isocost that crosses my isoquant. Oh, it's right here. It's our all X, our Alex solution. As I mentioned, this is going to correspond to 35 units of good 1. Each unit of good 1 costs $8, so the total expenditure on good 1 to produce those 70 units is going to be $280, right? All right, so now we've got Farmer Bob. Remember I mentioned the Farmer Bob problems? So we've got Farmer Bob producing n units of fertilizer per acre. Marginal product of fertilizer is 1 minus n over 200 bushels of corn. If price of corn is $4 per bushel, price of fertilizer is $1.20 per pound. How many pounds of fertilizer per acre should Farmer Bob use to maximize profits? Well, this is a profit maximization problem. So you should think, oh, we're looking for PMP1 equals omega 1. And then it's a matter of just recognizing the data, the information we've been provided. So we have the output price, we have the marginal product, and we have the price of the input. So what are these? Well, our output is going to be corn, right? So the output price is 4, right? So 4 right here. Our marginal product, we were given that right here. You don't need to take a derivative of this thing. This thing is already the marginal product, right? So that's the marginal product. And then the factor price is 120, right? So now it's just a matter of algebra just cleaning this up. And we find, oh, we're going to need to use n pounds of fertilizer. It's going to be 140 pounds of fertilizer. All right, so the production function here, 50 times k to the 1/4 times L to the 3/4 exhibits increasing, decreasing, constant, or increasing then diminishing returns to scale, or negative returns to scale. This is going to be constant returns to scale. And the way that we know this is, remember, Cobb-Douglas production technology is going to be of the form A, or it's like some constant, some scaling constant, times L to the alpha times k to the beta. Yeah, we've got this written as k and then alpha, whatever. So, multiplication is commutative. I like writing it this way because oftentimes we fix capital in a short run situation, and it just makes sense to have that at the end of the problem. But whatever, regardless, the part that we care about right here is that if you sum up these exponents to 1, then you know you have constant returns to scale. If alpha plus beta sum to something less than 1, we have decreasing returns to scale. And if it sums up to something greater than 1, we have increasing returns to scale. So if this was just like L, or if this is just like 1, then it'd be 1 plus 1.25 is 1.25, and then be increasing returns to scale. Or if this was like 0.5, then summing 0.5 plus 0.25 would be 0.75, and then we'd have decreasing returns to scale. But here, 0.25 plus 0.75 is 1, so we have constant returns to scale. All right, now we've got a price discriminating monopolist selling in 2 separate markets such that goods sold in one market are never resold in another. That's key to being able to practice third-degree price discrimination. Is you get, well, any type of price discrimination, you've got to be able to block arbitrage opportunities, resale. All right, so it charges $5 in one market, 10 in the other. At these prices, price elasticity in the first market is minus 1.4. Right, so that's elastic. And price elasticity in the second market is minus 0.1. Ah, that's inelastic, right? I know this is inelastic because it's something less than 1 in absolute value. Remember, price elasticity of demand was percentage change in quantity divided by percentage change in price. So if you got something smaller than 1, it says we got a much larger percentage change in price, much smaller percentage change in quantity. That's the definition of inelastic demand. Problem is, we're actually not going to want to produce on the inelastic portion of the demand curve, because if you do, marginal revenue is going to be negative, right? Just draw a generic demand curve, draw a generic linear demand curve, linear marginal revenue curve. It's going to have the same vertical intercept, but twice the slope as the demand curve. And you'll find where marginal revenue crosses the axis, that's the revenue maximizing point, MR equals 0, is the first order condition for maximizing revenue. As you extend that line down below the horizontal axis, it becomes negative, and you'll notice that any marginal cost curve that you draw in to cross marginal revenue below the horizontal axis, right, MR equals MC for profit maximization, is going to reflect a price onto the inelastic portion of the demand curve, right? So, okay, so we definitely want to raise the price here because we want to get off the inelastic portion of the demand curve. We want to at least get to the point where it's unit elastic, and that'd be only in the situation where marginal cost is 0. The best answer here is we want to raise P2. We can say that for sure. You might have wanted to say, well, we'll raise P2 and we'll lower P1. And the reason why you might do that is if we had costs of 0, right, then we'd actually want to move to the point where demand was unit elastic, or we'd be interested in maximizing revenue, and or in principles of micro, we talk a lot about like what do you have to do to maximize revenue. Well, if demand's elastic, you want to lower the price. If demand's inelastic, you want to raise the price. However, that's not what we're doing here. Here we're trying to maximize profits. So costs also matter. We don't know what those are. And so we can't give any further guidance for this one right here. It could be maximizing, might not be, but we don't know in which direction it would have to change. But we do know without a doubt that they are not optimizing here because they are producing where demand is inelastic. Follow-up question might be, oh, but doesn't the monopolist want to produce on inelastic demand curves? No. So the monopolist wants to be the only alternative, right? When there's fewer substitutes, demand gets more inelastic, the demand curve gets more vertical, other things equal, that's good. And as long as we're not talking about a perfectly inelastic or a perfectly vertical demand curve, what the monopolist is going to do is produce on the top portion of the inelastic demand curve. So if you have a monopoly, what you want to do ideally, if you're setting only a single price, is you want to produce on the elastic portion of an inelastic demand curve, right? You want inelastic demand, meaning that there's relatively few alternatives, but you want to produce on the elastic portion so that you're producing on a portion where marginal revenue is positive, or at least not negative. All right, so question 7. A competitive firm's production function is going to be 12 times the square root of factor 1 plus 4 times the square root of factor 2. Price of factor 1 is 1, price of factor 2 is 2, price of the output is 4. What's the profit maximizing quantity of output? Let's just do PMP omega 1, PMP omega 2 twice, and then figure this out, right? So here's for factor 1. 4 is the output good. 1/2 was from taking the derivative here, bring the 1/2 down, multiply by 12, reduce the exponent by 1. Here's the factor price, right? So this is going to be 2 times 12 or 24. Or I guess I did a little bit differently in what I wrote out. And then let's see, this is 1 over x1 to the square of x1. Move that to the other side. So then it's going to be 24 times a numerator, square root of factor amount of input 1. Square both sides, 576x1. Over here, it's a little bit easier, kind of smaller numbers, and it just kind of cleans up. 4 is equal to square root of factor 2. Square both sides, we'll have 16 equals x2. You might look over here and you're like, wait a second, I don't see 576, and I don't, whatever. So, nope. Remember, this is the amount of the input. This is the amount of the input for factor 1, for factor 2. Now we have to find how much output. So we're going to evaluate this at 576 and 16, right? So it's going to be 12 times square root of 576 is, of course, it's going to be 24. So 12 times 24, and then plus 4 times 16, or 4 times 4 is 16. So that gives us 304. That's where that came from. Following relationship must hold between average total cost and the marginal cost curve. Yep, marginal cost is below the average cost curve whenever average cost is going down, and marginal cost is above average total cost whenever average costs are rising. So if average cost is rising, marginal cost must be greater than average total cost, as shown from the picture here, which we want to keep in mind for a little bit later on. In particular, this is going to be the minimum of the average total cost curve. The demand for my new book is given by the function Q is equal to 8,000 minus 100p. The cost of having the book edited and typeset is $7,000, and the marginal cost of producing an extra copy is 4, and I don't have any other costs. I'd maximize profits by, well, we just find the profit maximizing quantity for a monopoly, and then just have to verify that you're not going to make a loss at that point. So, all right, if this is the demand, then the inverse demand is going to be 100p equals 8,000 minus Q. So here's inverse demand. Marginal revenue is going to have the same vertical intercept, but twice the slope. So this is 1 over 100, so this becomes 1 over 50. Solving, we found the monopoly profit maximizing quantity is 3,800. Turns out, yeah, C is correct. You actually got to verify that you're going to have positive economic profit. So I calculated profits, and then the fixed costs were 7,000. Yeah, whatever this is minus 7,000 is going to be positive. So sure enough, C is correct answer. Ann Arbor Visitors Bureau is the exclusive national marketer of weekend getaway vacations in Ann Arbor, Michigan. At the current market prices, price elasticity demand is -1/2. To maximize profits, what should they do? Hey, that's the inelastic portion of the demand curve. We know without a doubt they got to raise their prices, right? Because marginal revenue is negative here. So just raise your prices. All right, so remember I said, this point is going to be useful in the future. Think about marginal cost crossing average total cost. That's going to help us with this one. Firm has short-run total cost function 4Q squared plus 100. And what quantity of output is short-run average cost minimized? All right, so let me get marginal cost. I'll just take the derivative here. It's going to be 8Q. And then I'm going to get average total cost. So divide this by Q. So it's going to be 4Q, and it's going to be 100 over Q. Set those equal. Marginal cost equals average total cost at the minimum of average total cost, right? And if I solve then real quick, right, just algebraically, we're going to get Q is equal to 5. Okay, suppose Zoom wants to engage in second-degree price discrimination by offering 2 different versions of their video conferencing service where all customers are offered the same menu of prices to choose from. They maximize profits by setting the price of the basic version equal to maximal willingness to pay of consumers with the lowest demand. Good. And the price of the commercial grade version equal to maximal willingness to pay of the consumers of highest demand. Uh-oh. What's the problem? Well, remember, we've got 2 issues with second-degree price discrimination. Everybody sees the same prices, and they just choose what's right for them. It's like when you go to a restaurant with your friends, right? You all face the same menu, but you all probably walk out paying something different. The reason why is because you look at what's on the menu, think about your preferences, and you kind of buy a meal combined with like total expenditure that's right for your taste and for your budget, right? But you could have bought anybody else's meal, right? And they could have bought yours, right? That's what's happening here is, well, both groups of consumers see both prices. The ordinary household consumers are going to see the commercial grade price and say, oh, that's ridiculous, we're not going to do that. And they're just going to pay equal to their willingness to pay because that's where we set this one, the low version. But the commercial grade consumers are going to look and say, wait a second, this price is exactly our willingness to pay, which means we have 0 surplus, or commercial grade, so 0 profits. So what are they going to do? They're going to skate by with the basic version, which is not what we want. We want to actually lower the price a little bit below the maximal willingness to pay of consumers with the highest demand so that their consumer surplus is the same or maybe slightly higher when they buy commercial grade rather than just getting by with the basic version. So the correct answer here is false. All right, now consider Bombas. Stock and apparel company maintains a buy one, donate one policy for all their sales. Assume demands given by prices equal to 120 minus Q. Bombas faces marginal costs of 20. Write out the monopoly's profit maximization problem, solve for profit maximizing output and price, compute price elasticity of demand. Suppose they actually produce the competitive quantity but sell an amount equal to the monopoly output at the monopoly price and donate the rest. Find the competitive quantity and Bombas' profits when they use this buy one, donate one policy. Is Bombas basically overcharging customers? Shouldn't they just sell me 2 pairs of socks for 20 rather than just 1 for 20? Okay. Here's a monopoly profit maximization statement, right? They're going to maximize by choosing the optimal quantity. Then they're going to let the price adjust. So here, just kind of filling out, I got this up here so you can look at that just as well, but we're going to have our demand. Here's going to be like, this makes us revenue by multiplying it by Q, P times Q, and then this is going to be minus cost. I just kind of cleaned up a little bit, took the derivative, and then first order condition gives us a quantity of 50. With this demand curve, with this demand curve, quantity of 50 corresponds to a price of 70. And then we can calculate price elasticity of demand at that price, right? So we kind of think of price elasticity. It's not exactly, it's a little bit misleading, but not super misleading to say elasticity is like point at a slope, right? Slope at a point, right? Here's a slope, here's the point. Anyway, so the slope of this line is going to be -1, right? Even solve, this is inverse demand, sorry. So for elasticity, we want to get demand, so it's going to be Q is equal to 120 minus P, dQ dP is going to be right here, -1, times P over Q. Well, P was 70, Q is 50, right? And so our elasticity is going to be -7.5, which is elastic because it's greater than 1 in absolute value. All right, now we got to compute our monopoly revenue, but our competitive costs. So our monopoly revenue is going to be 3,500, right? 70 times 50. Our competitive costs, the cost of producing 100 units, was going to be 2,000. So 3,500 minus 2,000 is 1,500, right? Are they overcharging me? Yes, but no. I mean, if they produce the competitive quantity, then they'd have zero profits, right? All firms with market power are going to produce a little bit less, maybe substantially less than the competitive market would, because that's where their profits come from. On the other hand, I mean, relative to other things that they could be doing with the monopoly profits, right? Donating and giving back. They say on their website that socks is the most requested item if you're at a shelter. Also, lots of people think about donating food, right? And that's important, but there are like soup kitchens and there's food pantries. Lots of times, if you're thinking about donating something, it's actually like toiletries and socks, but toiletries that are kind of an afterthought that people often don't think to donate and are maybe more regularly in need than food because of the way that the food pantries are relatively well stocked and then supported by communities. Okay, anyway, so suppose Ben wants to produce 100 snow cones as cheaply as possible. I could do this either with a machine or manually using, so here's my production technology. It's either 1/2 L plus 2K. What's the marginal product of labor? What's the marginal product of capital? So, and then given the wage of 4 and rental rate of capital of 5, how much labor and capital ought Ben employ? How much will it cost to produce those 100 snow cones? Okay, the marginal product is just the coefficient here. So it's like MPL is 1/2, MPK is going to be 2. Got that? MRTS, the ratio of marginal products, is going to be 1/4, right? It's going to be 1/2 divided by 2. 1/2 divided by 2 is 1/2 times 1/2, or 1/4. W divided by R is going to be the slope of my isocost, which is going to be 4/5 from 4 and 5, right? So what? The isocosts are going to be steeper, so my smallest isocost is going to cross my isoquant on the vertical axis. It's an all-Y solution. So you draw like your, draw your isocost and then draw your isoquant and draw steeper isocosts, and the steeper one's going to cross on the vertical axis. You should just sketch that out for yourself real quick. And then this is going to require 50 units of capital, 0 labor. That's going to cost $250 from 5 times 50. UMich Golf Course has 2 different demanders, faculty and students, right? So here's the demands for both. Cost of serving either is just 8Q. So marginal cost is 8. Find profit maximizing price and quantity. This is just standard third degree price discrimination. For faculty, it's going to be 84 minus 2Q is equal to 8. And then this yields a quantity of 38, price of 46. Yeah, you should write out the full monopoly profit maximization statement. I just want to give us the answer real quick. And same for students right here. So it's going to be price of quantity of 30, price of 38. What did I do to find the answer? Well, I just said, here's my inverse demand. Marginal revenue is going to have the same vertical intercept, twice the slope. I'll get the quantity, then evaluate the inverse demand at that quantity to get the prices. Right? What if we couldn't practice third degree price discrimination? What if we had to sum up these demands? So then the demand would be, 84 plus 68 minus 2p. You'd find the marginal revenue, set that equal to 8, and then you'd solve, and you know what the quantity would be? 68, right? Because these are linear demands, and so the quantity, when you sum up these demands and can't practice third degree price discrimination, it's going to be the same as when you do, right? With third degree price discrimination, the question is about how do you allocate the output that you've produced since the marginal cost is the same, right? So it's going to be 68 because it could be 38 plus 30. And then basically the task would be to find the price. I felt the exam might be getting a little bit long, so I didn't ask that question. All right, so window and deck washing business might choose 2 different production technologies, labor intensive, so F of L is 1/3 L. Capital intensive, each unit of output requires 1 worker with power washer. Find the labor and capital requirements for each production technology if we serve 12 clients' homes. What's the optimal business choice if we want to minimize costs? And it's well known rental rate of capital is more than double the wage. So the first part's super easy, right? We want to think about what do we need to be able to do 12 homes? Okay, so if output is 12, then 1/3 L equals 12, or L is 36, and of course this isn't using any capital, so it'd be 0. And then if output is 12, L and K both have to be 12 to be efficient, otherwise we're not minimizing costs, right? So this part, everybody should have got A pretty quick, but if you're reading through this too quickly, you might wonder, what is this even asking? And that's where you've got to take a deep breath, kind of read through kind of a little bit slowly, and kind of reflect on what the structure of the question is asking of you. Anyway, and that's it. That requires a lot of patience. Requires a lot of careful reflection, and having worked enough problems to be confident that you'll get there. Okay, so for the optimal production scheme, if R is greater than 2W, we want option 1, right? Rental rate of capital is more than double the wage. We want option 1. And so you could maybe even get a sense of that a little bit by just saying, oh, well, capital is really expensive. We probably want the one that's labor dependent. Here's how we can show this. We can look at like what's the cost to produce, you know, in this case, those 12 homes. So it's going to be 36 workers times W, whatever is the wage. And then it's going to be 12 workers times the wage plus 12 machines or whatever times the rental rate of capital. So 36W is going to be greater than what? In this case, 12W plus 12R. Solving 24W is bigger than 12R, or W over R is greater than 1/2. Or that's where I got this condition, 2W is greater than R, right? So it would be more expensive. So this is saying it'd be more expensive to use labor if 2W is greater than R, but the equality I gave you is the opposite, where it was R is greater than 2W. So if R is greater than 2W, you want to tip in the other direction, then you actually would want to use the option 1. Okay, and then the last one. So consider a profit maximizing firm with production function. Right here, consider the firm's factor demand function, write expression to show the profit maximizing output a profit maximizing firm produces. Yeah, this looks horrible. It looks absolutely horrendous. And you've got to kind of gather yourself and think about what this is asking. Actually, you could probably, optimally, we should have written like a disjoint demand as well. But I figured this is already difficult enough, so you know we kind of look. This is what I'm looking for people to be able to find. All right, so calculate the firm's factor demand function right here. So it's a profit maximizing function or profit maximizing problem. So it's going to be P times ln of x minus omega x, right? So PMP1 equals omega 1. Okay, so P times marginal product here is going to be, you know, derivative of natural log of x is going to be 1 over x. So it's going to be P over x is equal to omega. And then solving for x, right? Solving for x is going to be x is equal to P over W. Let's evaluate my production technology at P over W at my x, and this gives me the amount of output, right? Once I multiply that by the output price and subtract off the costs, right, then we get profits. Right? But that's all that we are doing here. Okay, very good. So this brings me to the end. The next video is actually the solution for the other class. But anyway, hope you enjoyed the video. Hope you found it useful. Like or whatever. It's a free way to support what I'm doing here. But otherwise, I'll see you next time. Bye.